Right, so let's look at our first example. We're going to start off with a polynomial function. What we want to do, the whole goal of the problem, is to analyze and sketch the graph of f of x equals negative x cubed plus 3x squared plus 9x minus 27, again, using no technology whatsoever. So if this were a simple quadratic, we covered graphing that in intermediate algebra and college algebra, but this is now a nastier polynomial function that we want to learn how to do this. Now in college algebra, you learn tricks such as the rational zeros theorem, you learn what the in behavior should be of this polynomial, you might even learn how to find you certainly learned how to find x-intercepts of it with using the possible rational zeros theorem and synthetic division. But we are going to try to use calculus to tell us even more. For instance, on college algebra, you could not find any maxes and mins or inflection points. You could only find x-intercepts, y-intercepts, and in behavior of the graph. So in behavior at the x-intercepts. So we're going to be able to do a much more accurate graph than we were in college algebra now that we have the skills of calculus analyzing the first derivative and the second derivative. So let's start off with what we could have done in an algebra class, which is determine the domain. Well, the domain's pretty easy because this is a polynomial, right? And what's the domain of any polynomial function? The domain of any polynomial function is negative infinity to infinity. So that wasn't too bad. The next thing we want to look at is x-intercepts. How do we find the x-intercepts? X-intercepts occur when the function is equal to 0. So y equals 0, right? You set the function equal to 0. So we have minus x cubed plus 3x squared plus 9x minus 27 equals 0. Well, this is a little difficult if you don't remember some of your factoring techniques. One of your factoring techniques is called factoring by grouping. If there's 4 terms, you can look at grouping the first 2 terms together and grouping the second 2 terms together. So look at what they have in common in the first 2 terms. In the first 2 terms, I see that we could factor out, and I'm actually going to factor out the negative, I always do. I'm going to factor out a negative x squared because they have 2 x's in common. So negative x cubed divided by negative x squared would just be a positive x, and 3x squared divided by negative x squared would be a minus 3 would be left over. Look at the second 2 terms, 9x minus 27, what do they have in common? Well, I can factor out a 9. 9x divided by 9 is x, and negative 27 divided by 9 is minus 3. So at this point in time, I know this is negative x squared times x minus 3. Plus 9 times x minus 3 equals 0. But now, why did I do that? This is called factoring by grouping. If you look, both of these have an x minus 3 term, and I could factor it even further. So this polynomial factors into x minus 3. What would be left from the first one would be negative x squared plus 9 in the second one. And this would be the factored version of that polynomial. So negative x cubed plus 3x squared plus 9x minus 27 factors into the factor x minus 3 times the factor negative x squared plus 9. Why did I want to factor it? Because factoring it, now we can set each one of the factors equal to 0 and find our x-intercepts. So x minus 3 equals 0, add 3 to both sides, we get x equals 3. Remember, an x-intercept is an ordered pair. It is a point on a graph. The intercept is the point 3, 0. It is not the number 3. If you put the number 3, it is incorrect. It is an ordered pair. You actually have to give me the ordered pair. So now we have the second factor, which would be negative x squared plus 9 equals 0. I'm going to subtract 9 from both sides. Actually, you know what? I'm going to add x squared to both sides. So I'd have 9 equals x squared. I'm going to take the square root of that, but remember, anytime you square root, you have to do a plus or a minus, right? Sorry, let me put the plus or minus on the correct part here. So square root of 9 is 3, so here we'd be getting x equals negative 3 and 3. Well, again, that tells me that 3, 0 is also an x-intercept. Well, I already had that one, but negative 3, 0 is another x-intercept that I need to consider. So these are 2 points, important points, that are going to be on our graphs. The next one we need to find is the y-intercepts. The y-intercepts are usually my favorite because they're so easy. To find a y-intercept, you just set x equal to 0. So if we plugged in 0 for x, we'd have negative 0 cubed plus 3 times 0 squared plus 9 times 0 minus 27. and that's going to give me a number of f of 0. I'm getting negative 27. So that tells me the point 0, negative 27, is going to be my y-intercept. So these are very important points. It gives me points to graph. Pretty easy to find if you remember your factoring techniques for your x-intercepts. Pretty easy to find here. Nice points on the graph. This is the information that I need from the original function. The domain, the x-intercepts, and the y-intercepts. Why is the domain important? Because that tells me where's this function actually defined. Now, if I want to find maxes, mins, and so relative extrema, also inflection points, remember they need to be part of the domain. So I've already looked at my domain. Okay, so now that we've analyzed the original function, we want to start analyzing the derivative of the function. So I'm just going to remind myself here. I'm going to write down the original function. The original function was, let me make it so I can see it, negative x cubed plus 3x squared plus 9x minus 27. So that was my original function. Now I want intervals of increasing, decreasing, and relative extrema, so I need to analyze the derivative of the function. So let's go ahead and find that derivative. Derivative is nice and easy because it's a polynomial function. The derivative of negative x cubed is negative 3x squared. The derivative of 3x squared would be 3 times 2x, which is 6x. The derivative of 9x would be 9 times 1, which is 9, and the derivative of negative 27 is 0. Here's my derivative. Again, I need to find the critical value, so I need to set it equal to 0 and undefined. This is never undefined because it's a polynomial function yet again, so I'm going to set it equal to 0. I need to solve this quadratic equal to 0. You can solve it however you want, so you could use the quadratic formula if you wanted. I'm going to try factoring, but what I'm going to do before I factor is I'm going to divide everything by negative 3. Because I see that negative 3 is a factor of everything, so when I do that I'd have, well, negative 3x squared divided by negative 3, it would be x squared. 6x divided by negative 3 would be minus 2x, and then positive 9 divided by negative 3 would be minus 3 equals 0. I need two numbers that multiply to be negative 3 and add to be negative 2. That would be x minus 3 times x plus 1 equals 0. Just double check in your head by foiling it out real quick. That's x squared plus x. Minus 3x would give me my minus 2x, then minus 3. So that does FOIL out correctly. I did factor properly. And now that it's factored, I can set each one of these factors equal to 0. So x minus 3 equals to 0. Add 3 to both sides, you get x equals 3. And then x plus 1 equals 0. Subtract 1 from both sides, you get x equals negative 1. So these numbers right here, if you remember, these are your critical values. So these are my possible maxes and mins. So what was our next step after finding those critical values? The next step was drawing that number line. So let's draw that number line, and it's going to be really important that we do this. Okay, we have the points negative 1. We have the points 3, or the x values, I guess I should say, not points. And again, we're plugging these into the derivative. We know the derivative is equal to 0 at both of those points. We consider our first interval, which would be negative infinity to negative 1. Our second interval, which would be negative 1 to 3. And our third interval, which is 3 to infinity. Now I create my sign chart by taking my x values, plugging them into my first derivative, which is, and I want you to be careful here, I'm going to use the factored form. But if you look at my factored form, what I've got to remember is I divided by negative 3 first. So I can't use just this factored form right here, the x minus 3 and x plus 1. I actually need that factor of negative 3 out in front. So the factored form of the derivative is negative 3 times x minus 3 times x plus 1. That's the factored form of the derivative. And let's be really careful with this. Let's choose a test point, something below negative 1. So between negative infinity and negative 1, I'll choose negative 10. Any number in between negative 1 and 3, I'll choose 0. And any number bigger than 3, I'll choose the number 10. So let's look at this. Plugging in negative 10, I have the negative from the negative 3. Negative 10 minus 3 is negative, and negative 10 plus 1 is also negative. A negative times a negative times a negative is a negative. Since that test point was negative, everything in that interval must be negative. Let's plug in 0. I have the negative from the negative 3. 0 minus 3 is negative, and then 0 plus 1 is positive. A negative times a positive is positive. Since that test point was positive, everything in that interval must be positive. Let's plug in the number 10. I have the negative from the negative 3. 10 minus 3 is positive, and 10 plus 1 is positive. A negative times a positive is a negative number. Since that test point was negative, that entire interval has to be negative. So why do I care about this? This tells me about my original function f of x. Where my derivative is negative, I know my function is decreasing. Where my derivative is positive, I know my function is increasing. Because the domain is negative infinity to infinity, I know these critical values are in the domain of the original function, which is the first part of needing to be a relative extrema. It has to be in the domain. The second part is I know from the first derivative test where I go from decreasing to increasing, I have a minimum, and where I go from increasing to decreasing, I have a maximum. So whatever my x point is when x equals -1, that's a minimum, and whatever my point is when x equals 3, that's a maximum. So in fact, let's go ahead and find those points. And the way that I find those points is, remember, I have to plug them into the original function. The original function being, well, let's look at it, it is negative x cubed plus 3x squared plus 9x minus 27. And again, the two values that I wanted to plug in here were x equals -1 and x equals 3, right? So if I plug in a -1, go ahead and use the table feature on your calculator. Type this into your calculator, the negative x cubed plus 3x squared plus 9x minus 27. You hit enter. Doesn't matter what start is, doesn't matter what step is. Ask x needs to be selected. Hit OK. Type in -1, I'm getting a -32. So again, that tells me the point -1, -32 is a minimum. Type in the number 3. When I type in 3, I get 0. That was one of our x-intercepts, right? So here's the point 30. I know that has to be a maximum. So that's all the information I need from the first derivative. Again, where is it increasing? It's increasing where the derivative is positive. That was the interval -1 to 3. Where is it decreasing? It's decreasing where the derivative was negative. There was two intervals. The first interval being negative infinity to -1. The second interval being 3 to infinity. Where did our maximum occur? Our maximum occurred at the point 30. Where did our minimum occur? It occurred at the point -1, -32. So there's all my information for my first derivative. Again, this is only step 2 of the process. I've analyzed the original function, I've analyzed the derivative. Let's continue on with this problem, and we're going to analyze the second derivative of the function.